Okay, we are on. So this is number 4 from the homework, and as you can see, we're doing a Taylor series centered at x equals -3 or a equals -3, and the function is e to the x. You might have a slightly different either function or center, but it's going to be the same idea. So as before, to find a Taylor series, you find the derivatives, and you quickly notice the pattern that the derivatives are all e to the x. So this gets a little bit boring, and so I'm just going to cut to this f in. The nth derivative is e to the x. So that's pretty straightforward, that all the derivatives are e to the x. So, in fact, that little snippet video that I showed you where Taylor Swift was explaining the Taylor series for e to the x, she actually, or maybe it was Elon Musk or whoever it was that was with her, that was totally fake, by the way. You probably knew that, these deep fakes. But anyway, there's a website apparently you can go to make people say whatever you want them to, including me maybe. But anyway, getting back to this, all the derivatives are e to the x, and so, well, it's all going to be e to the x. That's easy enough. And then a equals -3. What we'll do is we'll do f of -3 is e to the -3. F prime of -3 is e to the -3, and so on. I'm getting really sick of writing, so I'll just do this. That the nth derivative evaluated at -3 is e to the -3. So that's the setup. That's where we're going to start. Then to finish this up, all we have to do is punch this into the Taylor series formula. The Taylor series formula is this, and goes from 0 to infinity of f nth derivative evaluated at a divided by n factorial times x to the n. So that's the Taylor series formula. It's a way of coming up with a power series for any function. Any function. You name a function, I can come up with a power series. You name a point on that function for the center. That's going to be the power series. Okay, welcome. And so, oh, by the way, the other thing about this point a equals 3, it just means that the Taylor polynomials will be closest to e to the x near -3. It's not like they're going to be wrong for all the others, but it'll be closest at -3, these polynomials. All right, onward. So we do this for this, so this is going to look something like this. We already know what the nth derivative at -3 is. It's e to the -3, put an n factorial up there, and x to the n. In fact, that's it. Isn't it? Oh, I'm sorry, I blew it. Ah, darn. Let me back up. This should be x minus a to the n. Something was wrong. Sorry about that. Yeah, because we're centering this at x equals a, you do x minus a, and this, what that does is that zeroes out everything except for the first term. So if you plug a into this, it's a bunch of zeros. And whatever the first term is, which is going to be the f of a. Okay, so this will be x minus -3 to the n. So it should be this. I don't know if yours is exactly like mine or just similar. Let me just see what this says. It says, what is C1? Okay, so C1 is going to be for this. So C0 will be e to the -3 over 0 factorial, which is just e to the -3. C1 is going to be e to the -3 over 1 factorial, which is also e to the -3. C2 is e to the -3 over 2 factorial, which is 1/2 e to the -3. You probably get the picture. We can easily type these in. Let's see if I can do it right here on the fly. Okay, so this is going to be just e to the -3. And this will be also e to the -3. I'll just do this one, just to prove that, not 2, 3, over 2. Let's just see what it like. Does it like me? It does like me for those 3. The other ones are going to be similar. Oh, why? Why? Why would they do that to me? That doesn't make any sense. I hate them. Okay, this is going to be e, I'm going to do it right. Negative 3 all over 6, because that's 3 factorial, and then e. Why would you do, that doesn't make any sense. Why would you do that? Divided by 24. Okay, so there's my final answer. I'll get it right. There, I like mine better. Yeah, I guess the decimals are, I guess there's something. I much prefer this, so you can go your way apparently. All right, anything else from this? So this one is not on the quiz. The quiz is about the Maclaurin series. Just hint, hint. Yes? Number 5. Is it a Maclaurin series? It is. Woohoo! Okay, so for that one, I can't answer number 5 until I've answered number 1. So once I figure out how to make this bigger, there it's sort of bigger, and then we'll do this, F11, full screen. There, it's better. Okay, so I'm going to go back to number 1 just briefly, but we'll come back to it, Matthew, don't worry. So number 1 asks you to match up these different, that one I can see. It's the inverse tangent, or arctan, that I need to match up. It's letter B. So I just happen to know this. I'll explain, just give me a minute, and I'll explain how you could do this yourselves. Oh, the way you would do this yourselves is, first of all, match up the easy ones. For example, letter D. Letter D, you recognize, is the geometric series. So that's this. Also, e to the x should be an easy one. E to the x is, oh, down there, letter F. Letter F is e to the x. For the rest of them, you can do a variety of things. Like if you don't know what the Maclaurin series was for sine of x, you could look it up. But another thing you could do is you could just generate the first couple of terms. So the sine of x, you know that the first term, or the 0th term, when you plug 0 into here, you get 0. Then do the derivative, you get cosine of x, and plug 0 into cosine of x, you get 1. And then you do the derivative of cosine, you get negative sine, and so on. So you do the first few terms, and you realize, oh, it's this right here. Wait, that's the sine. Sine? Did I do that? Yes, I did that right. Took me a minute. Oh, no, it's not letter B, because there's not it's got to have factorial in the denominator. That's the big problem, is that the sine, it's not letter B. It looks like this. It's letter C. So don't be fooled. It's letter C. So let's put that in there. And then the cosine is easy enough to do. Natural log you could do. The hard one is the arctangent, but because that's my favorite function, I know it. But you could use the process of elimination by doing the other ones first and then working your way around to figuring out what that one is. So there are those. Let me just prove that I know what I'm doing here. Submit it. It's all correct. The reason why I wanted to do that is because now I know that the tangent, inverse tangent, arctangent, is letter B. So I'm going to write that down. Give me a sec. Arctan of x is the sum of negative 1 to the n times x to the 2n plus 1 over 2n plus 1. Does that look all right? All right. Okay, so let's go down to letter number 5 now. Now that we've got all that, let's go all the way down here to number 5, and it says that we want to find, oh, sorry, I should have showed you. This is what I wrote. So what we're trying to do is we're trying to find the arctan of 4x squared. I'll show you what I'm writing. So I don't like writing tan inverse, so I write arctan. It's the same thing. Let's see, 3x out front. Okay, so here is what I've written. There. So here's how we're going to do this. we take the Maclaurin series that we already know for this one and just make the replacement. This is exactly what we did with all of our geometric series back in the day. I know those days, they seemed so difficult at the time, but now it's like, oh, it was like happy memories of joyful times. They weren't so bad, were they? So here's how this is going to work. We're going to take this thing right here, and it's going to go in place of this thing up here. Where is that thing? It's right there. Everything else I'm going to leave all the same. So give me a minute. I'm just going to duplicate all of that. Whoops. Copy, paste, there it is. So notice that the only thing I'm going to change is that thing right there. It will become 4x squared. And I'll even highlight that green. Now there's one more difference between the top and the bottom. And you probably are seeing, you're probably looking at it saying, why didn't he do anything with that? Yeah, I'm going to deal with it right now. That's this 3x. So that 3x has to go somewhere. I didn't leave myself much room. I will try to move everything over a little bit. There. So that 3x is just going to go right there. 3x. Now, in order to make Lumen happy, because we want to find the values of C for this one, what we're going to have to do is we're going to have to combine this, lump everything together. So let's see if I can do that. So I'm just going to rewrite. I don't know that you need to go quite as extreme as I'm going to go right here, but we're going to do this. So I'm going to move the 3 inside my little thing, and then you have 4 to the 2n plus 1 times x times x squared to the 2n plus 1, which is x to the 4n plus 2. So I tried to do, I'm trying to be kind in doing things one step at a time, although this is like 3 steps, but you can see everything ended up where down here. The -1 is here, the 4 is there, the 2n is here, and then the x squared to the 2n plus 1 becomes x to the 4n plus 2. Now I'm going to do one more combination here, and then we'll be all set. So, oh, this should be n goes from 0 to infinity. -1. Like I said, you probably don't have to be as extreme as I am with this one, but I just like to make it look pretty. 4n plus 3. That combines my x to the first with the 4n plus 2. All right, so let's pause, see if you're happy or not. Maybe you're not happy. I don't know. Reasonably happy? Sort of happy. All right, no one's going bonkers, so let's do this. Last step is to rewrite or write this out. So here's what I'm going to do is I'm going to start at n equals 0. I'm going to plug n equals 0 into this. N equals 0. Oh, sorry, I forgot my n here, didn't I? Yeah. Okay, so when n equals 0, I get, let's see, -1 to the 0 is 1 times 3. So I'll just write 1 times 3 times 4 to the 2 times 0 plus 1 is 1, all over 1. So that's, oh, times x to the 4 times 0 plus 3. Whew. So that's n equals 0. Let me do 2 more, and then we'll see how this relates to what we have on the on Lumen. Okay, the next one, when n equals 1, so this will be n equals 1. I have -1 to the first power times 3 times 4 to the third power, all over 3, times x to the 7th. Let me just pause for a minute and see if you see where all those numbers came from. All I did was I replaced the n with 1, and I got 4 times 1 plus 3 is 7. This becomes 3. Everything else is what it belongs to be. So there's n equals 1. Let me do one more. Shift over a little bit further. Okay, so we'll do n equals 2, and then we'll see how we're going to deal with lumen. Negative 1 squared times 3 times 4 to the 5th, all over 5 times x to the, let's see, 2 times 4 plus 3 is 11. Does that look right? I'm going to put some dots here because there are more stuff. There's more stuff. Let's grab lumen. Can I make this? Let me un-F11 this. There we go. Just a sec. Okay, so you'll notice that they're asking for these coefficients, C3, C5, C7, and you might be wondering, how does that relate to n? Well, the C3, that's the constant, which is in front of x cubed. So that's what that refers to. This is C5. This is the constant that's in front of the x to the 5th. The next one, the constant in front of x to the 7th. So let's look at this. Here is the constant in front of x to the 3rd. It's just whatever that is. 3 times 4 is 12. So it should be 12. I sure hope so. If I'm wrong, I will be embarrassed. Well, if I'm wrong, I'll fix it, not to worry. C5, let's go back here for a sec. Let's see, the constant that is in front of x to the 5th. Wait a sec. There is no constant in front. There's no x to the 5th, is there? So the constant in front of x to the 5th is 0. So I'm going to put a 0 there. Once again, I'm a little nervous, but we're going to, hopefully I'm right. We're going to find out in a sec. Let me just do this next one. The constant in front of x to the 7th is negative. That's 64 times 3 is 100 and, what is it, 28, 96? No, 192? Is that 64 times 3? Oh, but we're going to divide by 3. Doesn't matter. 64 times 3 divided by 3 is 64. So we have negative 64 as my, so I'll do that, negative 64. I'm just going to see where I am now to see if I got it right. I pressed enter. Why is it not? Do I have to press something else down here? Submit? Okay. I got it. Good. Phew. I was worried that I got them. I was a little worried about the 0. Okay, so C9, we're almost done. C9 is the coefficient of x to the 9th, which is 0. And then C11 is the coefficient of x to the 11th, which is negative. I'm just going to see what it does if I just type it in as 3 times 4 to the 5th over 5. Let's see, 3 times 4 to the 5th over 5. I'm so curious. Does it work? Hold on a minute. Oh, I got it right. Yeah, okay. So apparently you can just type in whatever you want. But there's mine. You might have had slightly different numbers, but that's the idea behind this, like how to do these. Anything else? All right, that wasn't too bad. Let's try it on a quiz. Okay, this quiz has 2 parts to it. So before I give it to you, let me just explain. There's the top part and the bottom part. We're going to go over the top part together, but you're going to try it. Okay? So I'll even tell you what the top part is. The top part is question 1 from your quiz. All right? So the top part is this, all of this. I'm just curious if you know the answers to question 1 from your quiz without looking at your notes. So don't worry if you get it wrong, because we're going to go over it. You don't have to cheat or anything like that. Do it honestly. And if you want to move on to the second part, the non-matching part, you can, but after I get done passing this out and giving everyone about a minute or 2 to do it, I'm going to go over the answers to part 1. That way you can be sure that you get the part 2 right. So go ahead and do the matching when you get this. And if you want to proceed, you can, but you don't have to. this is not, there's way too many, but there's one for gather. I hope. Let's see. There, you got one. Who needs one? Why do I have so many extras? So I can take a photo. Yeah, so if you want to proceed to part 2, you can before we go over this, but you don't have to. All right, let's go ahead and go over this just to make sure that you've got it straightened, because if you don't have it straightened out, then the writing out the Maclaurin series at the bottom, you'll get wrong probably if you don't have the correct matching here. So I'll go through this, the easy ones first. E to the x, hopefully everyone knows that e to the x is letter C. So you see that one? And hopefully you know that the 1 over 1 minus x, that is letter E. That is your geometric series. Now moving on, these two up top, those are the two trig functions, sine and cosine. So you just have to sort out which is which. And one way to remember is that cosine is an even function, and so it only has even powers. And sine is an odd function, and it only has odd powers. So if you remember what even and odd means, even means it's symmetric about the y-axis. Let me draw this just in case you're like, why is he talking about even? Okay, here's what even is. It's something that looks like this. So notice that would be a degree 4 maybe polynomial, would look something like that. Anyway, an even function only has even terms. An odd function looks something like this. Let's see if I can do this. So that that this part here, did I separate? Yeah, that part. If I flip it around, it should match up with the other part. I guess I didn't flip it around perfectly. Whatever. You get the idea, though, hopefully. Anyway, that's those. The last two, arctan is the one that looks suspiciously like the, what's it called, the sine. And then the other one, the leftover. What's leftover? Oh, letter F. Letter F is that natural log of 1 plus x. Is that you could derive, all of these you could derive from scratch because you can do your derivatives. These all have relatively easy derivatives, except for maybe the bottom one, but that's the geometric series. But arctan isn't the greatest either, I guess. Well, oh, but you know what you could do is you could do the derivative of arctan and then realize that you could use the geometric series for that. Okay, so now you've got those hopefully straight. Everyone got them right now? If you didn't get them right, fill it in. That way you'll know which one to use. You're going to use letter B for the first one. And what's the last one? Of course it's an arctangent, and so you're going to use letter D for that one. So do your best with those. And those I'll actually collect. Well, I'll collect it all, but hopefully you'll fix the top if you got it wrong. Okay, do it, and then we'll move on. Oh, one more thing. Sorry, I know I'm interrupting you again. Here, let me just go here for just a sec. I know you can't see. Let's show you this. Okay, so when I say show me the Maclaurin series, here's what I'm hoping for. Is either, let's see, either this one or this one's even better. So this one is super happy. That one. But that one up there is okay. So just rewrite it and then move everything inside the stuff. And it would be nice if you separated the x's as well. So there it is. Oh, I'll leave this up here so you can gaze upon the beauty of that Maclaurin series. And I'll freeze that. Phew. Had a little trouble writing it myself, so if it's taking you a minute, it's fine. Well, some of you are just meditating on something, I don't know what. So if you're done, I can take what you've got there and you can gaze, meditate on this while I gaze. Sensing that everyone got the first part right. Amazing, good job. always get back home, I'm walking around the house, and I get my 10,000 steps notification. My wife says, how did you do that? I wander around. All right, we're coming around. Making the rounds. You got something? Looks good? Looks great. All right, I think I got them all. Do I have everything? Why is it that I have so many extras up here? I feel like I always print too many. Okay, staple, done. Okay, let's see what I got. Hopefully you got something similar. If it's not identical, it doesn't mean it's wrong. It just means that you just didn't simplify it quite as much as I did. So here's my first one, or the first of the two, and I used that Maclaurin series up there, the second letter B. This is sort of minimalist. This is the, you're writing down exactly, literally what this is. It's 3x to the fifth, and then you've got the 5x in place of the x up there, and then the rest of it is just copied down from up there. And then I did some simplification. Hopefully I did my simplification correctly, so that I got, I got what I got. So yours, like I said, yours might not look exactly like this, but at the very least, bring this inside. And it would be nice if you separated out the x's so that the x's are by themselves, even if it doesn't look as pretty as mine. Okay, this beautiful arctangent, let's take a look at that. Once again, I'm just copying this from above the arctangent, whichever one that was, D was it? So I copied it and I replaced the x with 4x to the fifth. That's it. I put the 2x to the third up front. And then a little bit of simplification. I skipped a bunch of steps here, so this one I'm a little bit worried about. But let's double check my x's. So I moved that 2x cubed inside the summation. And then you have x to the fifth to the 2n plus 1. Multiply those together. You get x to the 10n plus 5. And then you got the extra 3 x's is there. And the rest of this, I think, is correct. So, looks pretty good. Okay, we don't have a lot of time today because we're going to try to end by about 10 so you guys can get good seats for the chapel service. We're going to take a look at two problems. Two problems, that's it. And here's what I want to do is I want to find the actual value of this summation. So we're trying to loop around and trying to answer the question of why. Why did we spend a month and a half on sequences and series? We're getting there. So one reason is for things like this. We're always curious as mathematicians, can we add up an infinite number of numbers? And the answer is yes, we can, of course. We're awesome, we're mathematicians. So this one you can do. I know you can do it because you have a formula for this. So take a minute, jot down what you think the answer is, and then I will do it for you. I don't want to embarrass anyone, or maybe I don't want to make anyone prideful because they know the answer. How's that? Because I know you all know the answer. Okay, so what you're seeing here is a geometric series. You know the geometric series formula. Let me just rewrite this slightly. 1/2 to the n. You're double checking. 1/2 is between -1 and 1. And so you can use this formula, 1 over 1 minus the common ratio, which is going to equal 2. Very nice. That's the sum for that particular series. So if you have a geometric series, you can easily find the sum. Oh, I just fibbed to you. I said that we were only going to do 2, but I'm going to throw a third one in there. Give me a sec. I need to find the third one. How about this? Let us do this as the second one. How about this? The sum where n goes from 0 to infinity of, how about -1/2 to the nth power over n. That one looks like fun. Okay, so this one is a little bit different. This is not a geometric series. So this will be, I lied, we're actually going to do 3. Here's the third one, by the way, down here, just so you know, it's the planned one. This one was unplanned. It is ad hoc, if you will, or impromptu. We are going to do the series nonetheless because it's fun. Okay, so this one, at first glance you might say, well, I can't do that because it is not geometric. Well, sure, it is not geometric. However, if I manipulate it slightly, very slightly, it will look like one of the Maclaurin series that's on this page right here. I'll show you which one just momentarily. Let me do the rewrite. So if I rewrite this like this, oh, crud. I can't start at 0, I have to start at 1. Anyway, oh, crud. I just realized that is wrong. I'll fix it on here. So on your quiz, the Maclaurin series that I'm about to use is incorrect. But I'll fix it. It's not a big deal. It starts at 1. It doesn't start at 0. But anyway, there's that. Now that I've got that fixed, here's how I'm going to write this. I'm going to write it as -1 to the n times 1/2 to the n all over n. Now, here's the thing about this one. This one looks suspiciously similar to up here, that one right there. Here, I will fix this, because that should go from 1 to infinity. Okay, so we've got that. Let me just rewrite it, or not rewrite it. I'm just going to take this and copy this. You know what? I'm so lazy. I'm just going to copy this whole thing. Copy and paste, because I can. Let me put this down here. Where to go? There it is. Okay, so I've got that right there. Now that I've got it right there, do you notice how this is exactly the same? Now, just like up here, I had to be conscious of the fact that 1/2 is in the interval of convergence for this geometric power series. So you have to check that before you do the formula. So we would need to know the interval of convergence for these series up here, and I omitted them, didn't I? I left them off, partly because this one, oh no, not this one. Sorry, the top 4. Maybe I'll just say it that way. The top 4. So the sine, cosine, arctangent, and e to the x. All of those converge for all values of x. The last 2 are the problem children. This one here, this one is the geometric power series. It converges as long as x is between -1 and 1. That one is the natural log power series, and it converges as long as x is between 0, why did I put a parenthesis there? I don't know, and 2. So those are the limits for that one. I don't think there's anything else I need to mention about that, so let's go back down here to here. So let's ask ourselves, is x between 0 and 2? And the answer is yes, it is. And so I can use this. So what does this equal? This is equal to the natural log of 1 plus x. If you didn't know it, you would have figured it out by process of elimination, or you could just look this up in some table of these Maclaurin series, which I'm debating over whether or not to have the actual table on the quiz or just have a problem like this. We'll see. Maybe we can negotiate. Anyway, so there's that. So I can just do the same thing up here and just mind that we're going to replace the 1/2 with x. So this is, did I get that written right? Is it 1 plus x or 1 minus x? It's 1 plus x. It just seems a little bit weird. And we're going to find out how weird it is. Seriously? Sorry, it still feels wrong to me. Well, let's just barrel on ahead, right? And then we'll see if we're wrong or right. Okay, so this will be the natural log of 1 plus 1/2. Sorry, it's just bothering me. Natural log of 3/2. Okay, let's see if this makes sense or not. This does not make sense, I don't think. I don't like it. Okay, let me double check that I've got this printed right. Did I print it wrong? Here, let me just check. It just feels wrong to me. Where is it? There it is. Oh, n plus 1. Ah, there it is. Okay, n plus 1. There it is. I have a slight mistake in my power series representation for natural log. So let me fix it. Fix it over here. So this should be an n plus 1 right here. I can fix it through the magic of the iPad on my iPad here. Wow, I guess it's good that I did this ad hoc problem. Come on, move that over. Ooh, that n just got separated from its, try again. There we go. So I want to make this n plus 1. Wow, I had all sorts of mistakes here. Let's blame it on sleep deprivation or something. I'll just fix this down here. Come on, slide over. Okay, this feels better to me. Okay, this feels better. Okay, the reason why this is important is because back here, okay, so this should be -1 to the n plus 1, and so I need to sort of put another -1 somewhere. So that'll become the negative of the natural log. Okay, this feels much better. Negative of the natural log of 1 plus 1/2, which is the negative of the natural log of 3/2, whatever that is. I don't know offhand, so I'm going to use my calculator. I know it's embarrassing, but I'm going to do it. Natural log of 1/3 is 0.405, so this will be negative 0.405 is my answer. Whew. I guess this is sufficient. I like that. Okay, one more, and we have 5 minutes to do it. We can do it, is this one. So this looks sort of similar. So let's see if we have something that looks like this. So n goes from 0 to infinity of n times 1/2 to the n. It looks suspiciously like the geometric series. And so we go back to the Maclaurin series that we're familiar with. I know I keep scrolling, you're getting dizzy. And unfortunately, none of these match exactly what I have down there. Maybe the closest one is D, but even that isn't quite right. So I need to do a little bit of work before I actually do this one. So what I'll do is I'll notice that the derivative, n equals 0 to infinity, the derivative of this, that's the geometric power series. If I do the derivative of that, check it out. That ends up equaling the sum, where n goes from 0 to infinity, of n times x to the n minus 1. Why can't I write? I don't know. There we go. Isn't that cool? And so what you could do, you'll notice that this now looks very much like this. The only difference is that that's, here, I'll do it like this. I'll pull out one of the 1/2s so that you can have 1/2 to the n minus 1. So 1/2 times the sum, where n goes from 0 to infinity, of n times 1/2 to the n minus 1. Now it matches up perfectly. So the last thing that we're going to do is we're going to do the derivative. So that is a power series on the right. And what is it the power series for? It is the power series for the derivative of 1 over 1 minus x. And the derivative of 1 over 1 minus x is the 1 over 1 minus x quantity squared. You're using the chain rule there, so if you need to, you can work it out. But you should get that. And so that means that this sum up here will be 1/2 times, so the 1/2 is out front there, times 1 over 1 minus 1/2 quantity squared. I can finish this up now. 1/2 times 1 over 1/4, and that also equals 2. If I've done my math right. interestingly. That is surprising to me. Okay, so there's one last thing. Cooper?
It is 3/4 to the bottom.
Oh, it is. That's why it's so surprising, is because it's wrong. It's going to be 2/3. Okay, so 2/3. Thank you. You're right, because it's 1 minus 1/2. Hold on a minute.
Yeah, then,
See, you led me astray. It's not 1 minus 1/2 squared. It's 1 minus 1/2 quantity squared. Okay, I'm going back to my original. Why do I doubt myself? I don't know. It's because I make plenty of mistakes. But anyway, there it is. It's 2. Okay, so the final thing is, does this really converge? So is 1/2 in the interval of convergence for this? And the answer can be had by looking at the interval of convergence for that. And the interval of convergence for that is that x has to be between -1 and 1. And sure enough, 1/2 is between -1 and 1. So we're all happy. I'm going to move the homework because we didn't get as far as we wanted to, or as I wanted to. You don't care. So I'll move. If you want to get started on the homework, you probably can do about half of it. But I'll just shove that down, the one that's supposed to be due tomorrow. It'll be due on Wednesday, and that'll give you a little bit of breathing room for today. So go get a good seat. If you get up front, maybe you'll get splashed. Did you think there's a splash zone? No, that's probably a little sacrilegious, right? Hopefully there isn't. All right, that's it. Stick around if you want to chat.